Right, children. Now we are going to start the next chapter. Now, do you remember in the previous chapters we learned about generating heat and we learned about effects of heat. Now, I told you all under effects of heat, we are going to learn under 4 topics. The first 2 topics we have already completed. What are the first 2 topics, children? We learn about increase of temperature and expansion. Now we are going to start the third topic of effects of heat. That is change of states of matter. What is matter, children? Do you all remember in the second lesson, we all learned that the things in the environment can be divided into 2 parts as matter and energies. What is matter, children? Matter means the things with a mass and that occupy space. There are 3 states of matter. What are they, children? They are known as solids, liquids and gases. Right, children? So, change of states of matter. So, under this one, we are going to learn that when heat is provided, matter can change from one state to another state. Okay, let's go through this. Heat changes the nature of objects. Ice is changed into water because of the heat. Look at this picture, children. Ice, water and water vapor. Right? Ice is a solid substance. Okay? Ice is the solid form of water. And this is liquid water. Day-to-day life, we all use liquid water to drink, right? And for our day-to-day activities as well. So, the water that we use in day-to-day life is present in its liquid state. Okay? So, have you ever observed what happens when we boil water? You must have seen when we boil water using a kettle, through the spout that smoke goes out. Right? This is water vapor. Okay, children? So, when we heat water, what happens? Water turns into water vapor. Water vapor is the gaseous state of water. Right? The same substance but in 3 states. Okay? So, you all know that when we take ice cubes out of the refrigerator, it starts melting, which means solid ice turns into liquid water. Right? So, when we boil water, when we heat water, what happens? It starts boiling, and when the water is boiling, it gives out water vapor. Okay? So, what happens when water is boiled? Water is changed into water vapor. Ice is changed into water because of the heat. Because when we take ice cubes out of the refrigerator, the environmental temperature is higher than that of the refrigerator temperature. Right, children? Because of absorption of heat, what happens? Ice starts melting, which means solid turns into liquids. Okay, children? So, here the water has turned to its gaseous state. Water is changed into water vapor. Here the water has turned to its gaseous state. Right? These types of changes are known as changes of state. So, what is the reason for these changes of state? Solids turned into liquids, liquids turned into gas. Right? So, when we supply heat, even though we don't supply heat when we take these ice cubes out of the refrigerator, it automatically gets heated up than it was before. Right? Let's see that if you take some ice cubes to a boiling tube, and when we start boiling, what will happen? First, these ice cubes will melt. So, which means when we supply heat, solids will turn into liquids. Ice into water means ice is the solid state of water, right? And this is normal water that we use in day-to-day life, right? So, when we further heat this water, what will happen? Its temperature increases. Do you remember we did this one activity to show how the temperature increase in water when we heat it, right? So, when we heat water, what happens? Its temperature increases, and at one point, it will start boiling. What is this temperature where the water boils, children? 100 degrees Celsius. We observed it during our activity, right? Okay. So, water starts boiling. Boiling means liquid water changes to gaseous water, which is known as water vapor. Okay, children? So, all these changes take place because of supplying heat. Therefore, change of states of matter is also can be considered as an effect of heat. Right, children? Okay. Look at this one. Change of state can occur due to the release of heat as well. So, we'll go through this. We'll start from this side. Water vapor means the water present in its gaseous state. What will happen because of release in heat? If we cool this water vapor, what will happen? It will again change into liquid water. Right? So, when we cool this liquid water, what will happen? If we place some liquid water in refrigerator, in the freezer part, what will happen? It will turn into solid ice. Right? Thereby, by placing this water in the refrigerator, what do? We reduce the temperature. Right? When we reduce the temperature, the heat will be released from the objects. Because of the releasing of heat, it changes the state. Okay? So, changes of state can occur due to the release of heat as well. Release of heat. When water vapor is cooled, it turns into water. When water becomes cold, it turns into ice. So, in our day-to-day life, this is a common experience that we all can observe. Right, children? So, look at this one again. Water vapor, by releasing heat, when it cools down, right? By releasing heat, it turns into liquid water. So, liquid water cools down, which means heat is released. What will happen? It turns into ice. Okay? So, we'll write the same two equations in the same place, right? Ice, water, water vapor. Right? Ice is in its solid state. Water in its liquid state. And water vapors in its gaseous state. Right? So, when we heat ice, what will happen? When we heat ice, on the arrow we will write heating. Right? When we heat ice, it turns into liquid water. When we heat water, it will turn into water vapor. Right? The same thing we can write in different way to the other side. When water vapor cools down, by cooling, we can change this into cooling. By cooling, we can change water vapor into liquid water. Right? In the same way, by cooling water or liquid water, we can convert it into solid. Okay, which means ice. Okay, children? So, ice upon heating turns into water, and water upon heating, further heating, turns into water vapor. Right? By cooling, we can convert water vapor back to liquid water, and by cooling water, the liquid water further, we can convert it into ice or the solid water. Okay, children? So, this is known as change of states of matter. This is the same matter, right? There are three states: solids, liquids, gases. Okay, children? We'll move on to the next. Right, we have an assignment to do here. Given below are some instances of changes of state. Write the change of state in front of it, right? Here in this column, given the instance, this column, you have to write the change of state. Okay. Look at the first one, it's already done here. Water convert into water vapor. We already discussed this. When waters convert into water vapor, water means the liquid state. Water vapor means the gaseous state of water. Right here, liquid into air. Air means the gaseous state. We'll write that one as well. Gas. Okay. Next one. Lead turn into liquid. What is lead? Lead is a type of metal. Okay, so lead is in its solid state. So when we heat lead, this metal up to a very high temperature, it will melt, which means it starts to turn into its liquid. Okay, so how to write? Change of state is lead is a metal, turn into liquid means the liquid state. Let's write solids, solid to liquid. Right, solid to liquid. Next one, iron turn into liquid. Now iron is also a metal. It is a solid. Turn into liquid, again the same thing. Solid to liquid. Solid to liquid. Right. Frost. Formation of frost. How is frost formed? What is frost, children? Frost means, normally in our country we can't see this frost, but in cold countries we can see. In the morning sometimes we can see, in the cold countries, a thin layer of ice is formed on plant leaves, and it covers the whole plant sometimes. This is known as frost, a very thin layer of ice. Okay, children? So what happens there? So even though we can't see frost in our country, we can see dew, morning dew. What is dew, children? You must have seen sometimes in the early morning, if you observe the environment, plant leaves have these type of tiny water droplets, and these are known as dew. Why does this happen, children? You all can see this early in the morning, right? So because early in the morning, the temperature of the environment is really low than the daytime. So then what happens, children? The water vapor in the environment cools down and it changes into liquid water. You all know that when we cool water vapor, what happens, children? It turns into liquid water. Right, children? So what happens? This liquid water deposits on the plant leaves like this, and this is known as dew. So during the formation of dew, what is the change of state that takes place, children? Water vapor changes to water. So water vapor is in its gaseous state. This is gas. Turns into liquids. Right? Change of state during formation of dew is gas to liquid. Right? What about frost? There, when forming frost, what happens? Water vapor present in the environment. Now, when the temperature is very, very cold, this incident takes place, formation of frost. Right? There, what happens? Water vapor straight away changes to solids. Okay, children? Therefore, that solid forms on the leaves and the other surfaces as a very thin ice layer. Okay? Therefore, during formation of frost, what happens? Water vapor straight away changes to solid ice. Okay? Right. So, frost, water vapor, which means gas. Change of state is gas to solid straight away. Right? The next one, producing ice cubes. What do we have to do to make ice cubes, children? We have to refrigerate. We have to put some liquid water in the freezer part of the fridge. Then what happens? Because of cooling down, liquid water turns into ice cubes, the solid water. Okay? So producing ice cubes, liquids turn into solids. Liquid into solid. Okay, children. So the first instance already given, water convert into water vapor. By heating this happens, right? Liquid water converts to water vapor, right? Or gaseous state. Lead turn into liquid. Lead is a metal, it's a solid. So there when it turns into its liquid, solid to liquid state, right? Iron turn into liquid again, solid to liquid. Frost means a thin layer of ice forms on objects in very cold countries. Okay. There what happens? Water vapor straight away converts to solid because of cooling down. Right? So gaseous state converts to solid state. And the last one, producing ice cubes. There, by liquid water, when it cools down, it turns into its solid state. Okay, children? Right. We'll move on to the next. We have an activity to identify solids, liquids, and gaseous states. Okay? Let's observe the changes in the state of matter. Right. Here, what do we need to do this activity? We need a candle, box of matches, and we need a white color cardboard, and we need a metal tube, right? Let's write. We need a candle, box of matches, white cardboard, and a metal tube. And a metal tube, right? How to do this activity? So look at the diagram. The candle is made up of solidified wax. Liquid wax can be observed when the candle is lighted up. You all can see when we light up the candle, the wax starts to melt. The solid wax starts to melt, and this is liquid wax. Okay? Wax vapor is seen in the dark region which is in the middle of the flame. Now we can't clearly see the wax vapor, but what will happen when we light the candle? The wax vapor acts as the fuel and therefore it burns here like this in the middle of the flame. Okay? So wax vapor is seen in the dark region which is in the middle of the flame. Right? We'll label these things first. This is solid wax, liquid wax, and gaseous wax present here. And this is the metal tube. Solid wax, liquid wax, gaseous wax or wax vapor, and this is the metal tube. Okay? Enter one end of the metal tube into the middle of the flame. That's where the wax vapor present, okay? Enter one end of the metal tube into the middle of the flame and keep another flame near the other end of the tube. What you have to do is, you have to enter this end of the tube to the middle of the flame and you have to wait for a few seconds, and afterwards you have to light another matchstick and you have to place it near the other end of the tube, metal tube. Okay? So you will see there another flame occurs. Right? When you place a lighted matchstick near this other end of the metal tube, you will see another flame forms. Okay? So another flame near the other end of the tube. Keep the piece of cardboard on the flame for a short period of time. So after observing this one, then you have to place the white cardboard near this other end and you have to hold it for a few seconds. Right? Then check the piece of cardboard carefully. Right, children? Now we are going to do this activity in the lab. Right, children? Now we are going to do this activity to show that change of state takes place because of heat. here I have a candle. So you all know when you consider the candle, candle is in its solid state. Okay. Now I'm going to light the candle. So what happens, children? When we light the candle melts. Right? Candle turns into, a part of the candle turns into liquid. Now look at this, children. So now this is the solid part of the candle. Can you all observe the liquid part? Right? The wax melts because of heat. When you light the candle, because of heat, the wax melts and it turns into liquid. Change of state. You all can see the liquid. So now where's the gaseous part of the wax present, children? Now can you all see the black color part of the flame? That is where the wax vapor is present. Okay, so wax vapor present in this black color part. So how to prove that wax vapor is present? Look at this one. Now I have a tube like this. This is a metal tube. I am going to hold this metal tube from here. Right? And then first of all I am going to light this other candle. Now I am going to hold this tube like this to the middle part. So when I hold this candle flame like this, if you observe carefully, you will be able to see another flame coming out like this. Check whether you all can observe. So why does this happen, children? When I hold this one end of this tube next to this area where wax vapor present, what happens? This vapor means a gaseous state of wax, right? This wax vapor comes through the tube to this side, and when we provide heat, what happens? Another flame occurs, right? Because of the burning of this wax vapor, another flame occurs. So it's very clear, even though we can't see here, now the solid wax present, liquid wax also you observe, even though we can't see clearly, gaseous state of wax is also present inside this candle, inside the flame. Okay, so to observe this change of state very carefully, now I'm going to do the same thing again. I'm going to hold this tube like this. Now you all know when I do that, wax vapor comes from the other side. I'm going to hold this white color board from this side. So what happens, children, when I hold it like that? Wax vapor goes to the other side and contacts with this paper of the surface of the paper. Right? And then I'm going to let it aside. Let it settle, and after it cools down, we'll observe what happens. Right, after letting it cool, I'll show you it like this. What can you see, children? This is the dried patch of wax. So what happens when I hold this tube like this? You all know that wax vapor comes from this side, and when I hold this paper, white color paper over the other side of this tube, that wax vapor get contacted with the surface and then it becomes the liquid wax instantly, and when it becomes cool, when we let it cool, what happens? It turns into solid wax, right? So if you observe carefully, when I scratch this part with the blade, can you all see? Right? So that is wax. Okay, children. So it's very clear, all three changes, all three states can be seen when we light a candle. The solid phase or the solid state, the liquid state, and the gaseous state or the wax vapor present in the inner part or this black color area of the flame. So all these things happen because of heat, children, right? So when we provide heat, so it's very clear, because of the heat, the solid wax turns into liquid wax and liquid wax turns into gaseous wax or wax vapor. Right, children? You all observed what happened. It was an interesting activity, right? So what did we do? We lighted the candle and then we placed this metal tube near the flame, inside the flame of the candle. and then we placed another flame at the other end of the metal tube, what happened, children? You could clearly observe another flame occurs at this end. Okay, children? Then what did we do? We held a piece of cardboard, the white color cardboard, next to this other end of the metal tube, and we kept it for a few seconds. And after a little while, when we observed, you could see the patch of the wax. Okay, so I showed you that a solid wax formed on the white color cardboard. Okay, children. So why does this happen, children? Now you all know you can observe all three states of this wax or the candle. Okay, children. So here we can clearly observe the solid wax. When we light this one, the wax melts, and the melted wax is known as the liquid wax. We cannot see the gaseous wax, but now we know that when we place the metal tube inside the flame, what happens? That gaseous wax, so the wax vapor goes through the tube to the other end, right? Wax vapor from this end to the other end, the wax vapor moves, and when we place another flame, what will happen, children? Because the wax vapor present there, this time the wax vapor acts as the fuel, and when we provide heat, what happens? It lights up and another flame occurs. Right, children? So when we place the cardboard next to the other end of this tube, what happens, children? The wax vapor that enters from the flame towards the tube to the other end, it contacts on the surface of the cardboard. Now when we consider the wax vapor's temperature is higher than that of the temperature of the cardboard. Therefore, when this wax vapor contacts on the cardboard, what will happen, children? It solidifies, right? The vapor changes into solid because of cooling down. Okay, children? Right, we'll write the observations and conclusion. Right, the first observation. When another flame is kept near the other end of the metal tube, another flame occurs. Okay? And when a cardboard is kept at the other end of the tube, solid wax deposits on the cardboard. Okay? When another flame is kept near the other end of the metal tube, another flame occurs. Right? Or we can simply write, when another flame is kept near the other end of the metal tube, a new flame occurs. We'll write it like that. A new flame occurs. When a cardboard is kept at the other end of the tube, solid wax deposits on the cardboard. So it's very clear that when we do this activity, we can observe the change of states of wax. Okay, let's write conclusion. Change of states of wax takes place. right? So how does this happen? Solid wax converts to liquid wax, converts to wax vapor. And we could see that wax vapor, first when we held the cardboard, it deposits as a patch, which means the liquid wax. And when we keep it another time, it forms solid wax, right? When it cools down more. So we'll write to the other side as well. Right? By cooling. Wax vapor converts to liquid wax. Further cooling. Liquid wax converts to solid wax. Here in these arrows we will write heating. Due to heating this happens. Right? So change of states of wax takes place. Right? So solid wax due to heating converts to liquid wax, and liquid wax due to heating changes to wax vapor. And the wax vapor due to cooling again converts to liquid wax, and liquid wax further cools down and forms solid wax. Right, children? So after doing this activity, it's very clear that because of heat, change of states take place. Right, children? Change of states take place because of heat. Okay, children? We'll move on to the next. Right, children? Assignment we have to do here. You all can do this at home, but you have to get the help of your parents because this is a kind of risky activity, right? Hold a plate to the steam that goes out from a spout of a kettle. Report your observations, right? So when you boil water using a kettle, you all can see when the water is boiling, water vapor or steam comes out of the spout of the kettle. When you hold a plate like this, when you hold a porcelain plate like this next to the spout, after a little while, after a few seconds, you will realize that tiny water droplets form on the plate. Right? This is the observation. We'll write that first. Tiny water droplets. This is the first we'll write observation. Tiny water droplets form on the plate. Tiny water droplets form on the plate. So why does this happen, children? When we consider the temperature of the steam, the temperature of the steam is very high. So when the steam gets contacted with the plate, what happens? Compared to the temperature of the steam, the temperature of the plate surface is low. Therefore, what happens? The steam that contacts with the plate surface is kind of cools down. You all know that when a gas cools down, it converts to its liquid. Therefore, steam means water vapor or water at its gaseous state. So when it contacts with a cooler surface, what happens? Its temperature reduces and it converts to water or liquid water. That liquid water deposits on the plate as water droplets. Okay, children? So we'll write the change of state takes place here. Change of state. Change of state takes place. Gaseous state. Gas converts to liquids. Right? What is the gaseous state? Water vapor. Water vapor converts to liquid water. Okay, children? gas converts to liquids. Gas changes into liquids. Right, children? Right, we'll move on to the next. Okay, we have another assignment to do. Take some wax, camphor balls, jack latex and tar. What are camphor balls, children? These are known as mothballs as well. Right? Jack latex and tar. Keep them in a lid of a tin and heat. What melts quickly? Right? So when you're doing this activity at home, if you can't find the same solids, you can find different solids that you can find. Okay, children? So here we are going to use wax, camphor balls or mothballs, jack latex and tar. Right? Jack latex is the sticky substance that comes out of the jack plant. Okay, that is known as jack latex and tar. So we'll do this activity in the lab now. Right, children? Now we are going to heat different types of solids and check whether which one melts first. Now look what we have here, children. Here I have a piece of wax. You all can see. This is a piece of tar. And this is camphor. Right? And this is jack latex. What is jack latex, children? Jack latex is the white color sticky substance that comes out of the jack trees. Now, normally it's white in color, but this one is a little dried up. That's why it is brown in color, okay? So, I'm going to light the spirit lamp first. We'll keep it under the lid. Check carefully. Already the piece of wax started to melt. Now you all can see jack latex starts to melt. And then camphor. And if you observe very carefully, you all can see the piece of tar also bubbling here, starts to melt. So it was clear that we had 4 different types of solids. They started to melt at different times, not at the same time, even though we provided heat at the same time, but they started to melt at different times. Right, children? So you observed what happened when we were heating these 4 different types of solids, right? They all melt and then turns into its gas, but they start melting at different times, okay? So we provided the heat in the same amount, same time period, but you observe that even though we provided the same amount of heat at once, what happened? They started to melt at different temperatures. So based on the nature of the solid, the change of state also takes place at different ways, different levels. Okay, children? So after discussing all these activities, I hope it's very clear that when we provide heat and the matter changes its states, solids to liquids, liquids to gas. And when the different substances cool down, when the heat is released from matter, what happens? They again change from gases to liquids and from liquids to gases. Okay, children, we'll move on to the next. Right. Color change. Now, this is the last effect of heat we are going to learn under this lesson. Okay, color change. What is the meaning of this color change, children? Right? We'll go through this. In a smithy, what is a smithy? Smithy means a metal workshop. Okay? In a smithy, when a piece of metal is heated, first it turns red and then orange. Gradually, when the heat of the object increases, its color changes. Some of you must have seen these type of metal workshops, and some of you all, it might be a new thing, right? So in a smithy, when a piece of metal is heated, first it turns red and then orange. Gradually, the color changes with heat, okay? When it is heated further, it turns yellow. Okay, children, when you heat it a little amount, it turns into red, and when you heat more, what will happen? It turns orange, and when you heat more and more, it turns yellow in color. Which means, according to the amount of heat, what happens, children? The color changes. Okay? We'll go through this one. A similar phenomenon means incident, okay? A similar phenomenon occurs when electric energy is provided to a filament of a bulb. What is the meaning of filament of a bulb, children? So when you consider light bulbs, there are different types of light bulbs. Filament bulbs are like this. There's a filament like this. This is the filament. Right, children? So if you observe carefully, you can see the color of the filament changes according to the way we provide electricity. Right? A similar phenomenon occurs when electric energy is provided to a filament of a bulb. Supply electric energy to a small torch bulb and observe the color of its filament. Now we are going to do this as an activity in the lab, okay? So what happens? First it will turn red, then orange and yellow respectively, and at last it will turn white. Right? This is the order. First it turns red, then orange, then yellow, and finally it will turn white. Right? What is the reason? The reason for this color change is the transformation of electric energy to heat energy. Right? So when we start to send electric current through this bulb, right? If we send a low current, what will happen? This bulb will get heated up less. Right? The filament will get heated up less. Right? In that case, the filament will be red in color. If we increase the amount of current that sends through this bulb gradually, what will happen, children? The filament color changes from red to orange to yellow to finally white. Okay, children? So we have to do an activity to see this. Now we are going to do the activity. Right. The activity. Observing how the color of the filament of a bulb changes with heat. Right? So what are the things we need? We need a filament bulb, a small filament bulb, and dry cells. What is this? This is a resistor. Right? In the electricity lesson, we learned about resistors. Now, this is a permanent resistor, but we are going to use in this activity a variable resistor. Okay? So, for the variable resistor, we are going to use a rheostat. In the previous lesson, I explained you all, rheostat is a type of variable resistor. What is a variable resistor, children? Variable resistor means an instrument where we can change the resistance. Okay? And we need a switch. Let's write. We need a filament bulb. Filament bulb. Dry cells. Variable resistor. And a switch. Okay? So how to do the activity? Method. Prepare a circuit using the materials given. Right. So what are the materials again? We need a filament bulb, dry cells, variable resistor, switch. Okay. So we'll draw the diagram using the circuit symbols. So the dry cells we'll draw like this. And we'll draw two dry cells. They are connected with the wires like this. And switch. And we'll draw a bulb over here. And how to draw the circuit symbol of a variable resistor. How to draw the symbol of a variable resistor, children? Look carefully. You all know that we can draw the symbol of a resistor like this, right? Permanent resistor. How to draw a variable resistor? We are going to draw an arrow like this across this resistor symbol. Okay? Right. So we'll draw here the switch. And here the bulb. Symbol of the bulb is like this. Okay, so this is how we make the circuit with 2 dry cells and a filament bulb, variable resistor. This indicates that the resistance can be changed. Okay, the same symbol we use to draw the permanent resistor, we can draw an arrow across the resistor like this, and this is the symbol of the variable resistor, and a switch, right? And control the current with the variable resistor and increase the current gradually and observe the change of color of the filament. Now, how do you control the amount of current flows through the circuit, children? You all know that when the resistance increases, what happens to the flow of the current? Reduces. What is resistance, children? Do you remember that we learned what resistance is? When you consider the electric current, resistance means, now when the electric current flows through the circuit, there is a certain barrier towards this electric current, and this is known as the electric resistance. Right, children? So when the resistance is very high, which means the barrier towards the flow of electricity is very high, what happens to the amount of current flows through the circuit? Reduces. Okay, children? So using this variable resistor, we can increase and decrease the resistance. When the resistance is high, the amount of current flows through the circuit is low, right? When the resistance is low, what happens? The amount of electric current flows through the circuit is high, right? So we have to gradually increase the amount of current that flows through the circuit. Right, children? And we have to observe what happens to the color of the filament of the bulb. Right? Let's do this activity now. Right, children? Now, with this experiment, we are going to show that the color of the filament of a bulb changes with heat. Okay, children? Now, you all know when you take these type of bulbs, there's a filament. Right, children? These are known as filament bulbs. Okay? So, remember, children, the color of the filament changes when the bulb gets heated up into different levels. Okay, children? So why does the bulb gets heated up into different levels, children? Based on the amount of current flows through the bulb. Okay, children? When less amount of current flows through the bulb, which means when the resistance of the circuit is high, the filament of the bulb gets heated up less, right? When more amount of electricity flows through the circuit, which means the resistance is very low, the filament of the bulb gets heated up more. Right, children? When the filament of the bulb gets heated up more, it gives one color. When the filament of the bulb gets heated up less, it gives a different color. So by this activity, we are going to observe that. So how can we control the amount of current flows through the circuit, children? Now you all know in the previous lesson, we learned about variable resistors, right? So when we connect a variable resistor to a circuit, we can change the amount of current flows through the circuit. Now here we are going to use a type of variable resistor, and this is known as the rheostat. Okay, children? Now here we have the circuit. You all can see this is the variable resistor or the rheostat. From this wire it is connected to the switch. Switch is opened, and from this wire switch is connected to these dry cells, and this sides of the dry cells connected to the bulb, and this side of the bulb is connected to the other side of the rheostat. Okay, children? Now I am going to close this switch. Right. So you all can see, even if I close the switch, the bulb does not light. That is because at this moment, the resistance of the circuit is very high. When the resistance is very high, you all know that the amount of electricity flows through the circuit is very less. Right, children? How can we change the resistance, children? Now, if you want to light this bulb, we have to reduce the resistance of the circuit. So, you all can see this part of this variable resistor. So, when I move this part from this side to this side, remember, children, the resistance gradually decreases. Okay, children? So, I am going to move it through this line Observe carefully what happens to the bulb. Right. Can you see a red color in the filament of the bulb? If you observe carefully, you can see it very clearly. Right, red color. Okay, children? Which means at this time, a very less amount of electric current flows through the circuit. Right, children? Now I'm going to move this part to this side more. Which means I am going to reduce the resistance more. Right. Look at the filament now. What is the color now, children? Now the color is orange color. Right now the filament is orange color. And I will move this part more. Right. Observe carefully now it is yellow color. Right. If I move this more, the brightness of the bulb increases. And you can see the color of the filament is white color. Right, children? The color of the filament is white color. Again, when I move this to the other side, now I told you earlier, when I move this part from this side to this side, what happens to the resistance? Decreases. Which means, if I move this part from this side to this side, the resistance increases. Right? What happens when the resistance increases? So now it's white color. I am going to move this part from this side to this side. It will go backwards. Now it's white. And it's yellow color now. Orange color. And now it is red. Okay, children. If I move it further, what will happen? The resistance is very high. Therefore, very less amount of electric current flows through this one. And it is not enough to light this bulb. Okay, children. Right. This time I am going to place this black color board behind this bulb so you can observe the color changes carefully. I am going to move this pointer from this side to this side again. Observe the color changes carefully, children. Okay? Right. So when I move it, first you all can see it is red color. Right? So now it is orange in color. Right? It's orange in color. Look now. It's yellow in color now. And finally, when I reduce the resistance more and more, turns finally into white color. Right, children? So after doing this activity, it's very clear that because of the change of heat in the filament of the bulb, its color also changes. Right, children? So you observe the activity. What did we do again, children? We connected the circuit like this with dry cells, a filament bulb with a variable resistor and a switch. So what happened? I explained you all how to increase and decrease the resistance using the variable resistor. Okay. So you all know that when the resistance is very high, what happens to the flow of electricity? Reduces. Right? So when we gradually reduce the resistance, what happens? The amount of electric current flows through the circuit is increased. Right? So with the minimum amount of current, what was the color of the bulb, children? Color of the filament was red color. So when we gradually increase the amount of electric current flows through the circuit, what happened, children? The color of the filament also changed from red to orange to yellow to finally red color. So why does that happen, children? When we increase the amount of current that flows through the circuit, the amount of current that flows through the bulb also increases, right? With more current, with more electric current, more heat is produced, right? When the heat of the filament of the bulb increases gradually, what happens, children? The color also changes. With less heat, red color. With more heat, white color. It gradually increases from red to orange to yellow to white. Okay, children, let's write the conclusion. Right. Observation. When the amount of current that flows through the circuit increases. The color of the filament changes as below. Red to orange to yellow and finally to white. Right? When the amount of current that flows through the circuit increases, the color of the filament changes as below. Red to orange, yellow to white. Okay? So what is the conclusion? Right. That's right. When the amount of current flows increases, the temperature of the filament also increases. Due to heat change the color of the filament also changes. Right? When the amount of current flows increases, the temperature of the filament also increases. Due to heat change, the color of the filament also changes. So what is the color change again? Starting from red, orange, yellow and white. Okay, children. So I hope it's very clear that because of heat, color change also takes place. So do you remember what are the effects of heat that we learned so far, children? We learned about 4 different types of effects of heat. What are they, children? Increase of temperature, expansion of solids, liquids and gases, change of states of matter, and finally, color change. Okay, children, we have come to the end of this chapter. I hope this was clear.